In this video, we're going to extend the map system with some methods that will make it easier to create more complicated structures on the map. Let's start by deleting these overlay methods to make more room to test the new methods. Now let's move down to the set cell methods we defined earlier. We're going to define some methods called set cell box. These methods will allow us to specify a pair of coordinates that will define the corners of a box, and then the box will be outlined or filled by the map type we provide. We are going to include an optional argument called fill. This argument will control whether or not the inside of the box is filled in with the map type. The default will be false, which means it will only outline the box with the new map type. The first thing we're going to do inside of the method is to swap the coordinates from each pair if the first coordinate is larger than the second. This will make it much simpler to iterate through the coordinates to draw the box. We want to be able to provide 2 points on the map without worrying about whether the first point starts at a lower coordinate than the second. We will get the same box either way, so this is just for convenience. Next, we're going to set up a nested pair of for loops to iterate through the coordinates in order to draw the box. The outer loop will start at x1 and continue until it equals x2, and the inner loop will start at y1 and continue until it equals y2. Inside the loops, we will first define a local Boolean variable called onEdge that will be true if the current xy pair is on the edge of the box. This will be true only if one of the coordinates is equal to its starting or ending value. Next, we will use an if statement to check if we should actually set the cell at this position. If the argument fill is set to true, then we will always place a tile because we are trying to fill up the entire box with the new map type. If fill is set to false, then we only want to set the cell if we are currently on the edge of the box. We can handle both of these cases with an OR statement. Now let's test out the new method. Let's try to create a box with one corner at 3, 3 and the other corner at -3, -3. This will test whether our swaps are working correctly, because if the coordinates were not swapped, then x would start at 3, which is already greater than or equal to -3. Fill is set to false by default, so we're expecting to see an outline of red floor tiles. We got exactly what we were hoping for. You can see the outline is 3 units out from the origin. Now let's test the fill argument by setting it to true. As you can see, we now have a filled box with our new floor tiles. Now we're simply going to copy this method to create the other 2 overloads, which will allow us to create boxes on the structure and overlay layers. There's nothing new involved here, we are just going to replace the map type in each overload. This is exactly what we did with the set cell methods. Let's test out the structure type overload by trying to create a room. We're also going to test out the symmetry of our method by providing the corners in a different order. We will call setCellBox with the wall2 type with the exact same size as our floor. The only difference being that we provide -3, -3 first and then 3, 3 second. There we go, we've now got a room with a floor and walls, and we didn't have to go around setting all of the cells individually. Let's jump over to the citizen class and set them to the wander state so we can see that the walls are working correctly. Right there, you can see that the pink citizen attempted to walk through the wall and he was placed into the idle state for a short moment before he chose a new direction. Notice they stop glowing when they are in the idle state. Let's set them back to the idle state now. Now we're going to follow our practice of creating vector overloads for our map methods. We're going to create a new version of each method that takes 2 vectors instead of 4 individual coordinates. We will call those vectors position 1 and position 2. Then we simply call the coordinate method and pass along all of the arguments, being sure to unpack the vectors correctly into their individual coordinates. We will now copy this method to create the structure and overlay overloads. That's everything we're going to do in this video. In the next video, we will introduce a UI that allows the user to change the movement state of the citizens from within the application.